Hello everyone, welcome back. Today we will look at question 647, which is palindromic substrings. So, given a string S, we want to return the number of palindromic substrings in S. So the first question would be, what is a palindrome? Let's look at the string mom. Well, a palindrome, as they define it, it's a string that reads the same backward as forward. In other words, it reads the same from left to right and from right to left. Okay, so that is a palindrome. Let's look at the first example that they are giving us. We have the string A, B, C. We notice ABC is not a palindrome, but the output is 3, as you can see right here. Now, why is that? Well, you see, the question is asking for substrings, palindromic substrings. So we're not only looking at the whole string, we need to consider all substrings, and for each one we need to see if it's palindrome or not. So how do they get 3? They are saying that A, B, C individually are palindromes. As you can see, A as an individual character, B and C, each one of those is a palindrome. That makes sense. So we know that we have the individual characters A, B and C, each one is a palindrome. But to reach this point, what did we do? Well, let's take a step back. We started at A and we noticed that A is a palindrome, so it will be included in the answer. But then we look at the other substring that starts with the letter A. We have AB. AB is not a palindrome. We check A, B and C. ABC is not palindrome. Then we go to B. B alone is a palindrome. Okay, then we go to BC. BC is not. Then we go to C finally, and C is a palindrome. So this question have two ideas in mind. One, we need all substrings of this string S, and two, for each one we need to see if it's a palindrome or not a palindrome. So this is the idea of the brute force. Given S, 1, we calculate all substrings of S. Step 2, each substring we evaluate if it's a palindrome or not. Now, I will show you the code for the brute force before we go to the optimization. But before that, let's make sure we have all the fundamentals down. How do we know algorithmically if it's a palindrome? Let's look at mom again. To check if the string is a palindrome, we will have 2 pointers. One pointer would be at the beginning of the string, and the second pointer would be at the end of the string. And now we check the character at each of these pointers. If it's the same, then we increase the left pointer and we decrease the right pointer. And we keep doing this until the 2 pointers meet. So that is how we know if the word is a palindrome. So now let's look at the brute force solution. Well, to begin with, we have just int n equals s dot length. I'm just making my life easier. I want to store the length of the string in the variable n, and we have count, which will store the number of palindromic substrings, which will we return. So step 1, we said we need to generate all possible substrings. So we have 2 for loops. Again, let's say we have the word mom. We will have 2 pointers starting at the first letter right here. So for int start equals 0, which is this first pointer, for each character we need to generate all substrings. So we have the 2 pointers. We will take the second one. We have m, then we have mo, then we have mom, right? Once we reach the end, we do what? We increase the outer pointer and we start again. We have o, then we have mo, etc. This way we generate all substrings. But what do we notice? Inside of the second for loop we have a isPalindrome function. Now this function I created as a helper method. You can create the whole thing inside of one function, but I like to keep myself organized. So we have isPalindrome function, and from the name this one checks if we have a palindrome. So inside of this helper function, exactly as we said, we have 2 pointers left and right. We have a while loop. Again, let's say we have mom. We have 2 pointers, one at the beginning, one at the end. This is left and this is right. and we check if the character on left is the same as the character on right, and we keep moving forward. Or in another way, we can say, hey, at any point, if the character on left is not equal to the character on right, we immediately return false. But if they are equal, what do? Oh, we increase left, we decrease right, exactly as we said. Increase left and decrease right. So this is the brute force. Generate all substrings for each one, check if it's a palindrome. So what is the time complexity of this brute force solution? Well, here we have a nested for loop, and this will be being O of n squared for this section right here. Now to check if a string is a palindrome, we need being O of n. Imagine we have A. We have the 2 pointers, right? And we will keep decreasing these 2 pointers until they meet. On the worst case, we have a palindrome, so we keep decreasing them until they meet. So we will go through the whole string. So it will be being O of n. Now, being O of n to check if it's a palindrome, being O of n squared to generate all substrings. But what are we doing? We are saying we want to generate all substrings, but for each one, we are checking if it's a palindrome. So the time complexity is being O of n squared times n, which is being O of n cubed. So the brute force solution gives you big O of n cubed. So now let's see how we can optimize this. Let's look at a palindrome. Let's take the word civic. C-I-V-I-C. Obviously, this is a palindrome. Now, if the palindrome reads the same from left to right and from right to left, what does that mean? Well, if we look at the center, all the characters around the center are the same. So the center is the letter V. We can see that we have I, then we have C. Okay, another one, mom. The center is O. We have M, we have M. So we can use this feature of palindromes that if we have the center, all the letters around the centers would be the same. So instead of generating all substrings first, and then for each one of those we check if it's a palindrome, no, we will take each letter and what? We will expand from the center. What does that even mean? We will start at each letter and we want to make that letter the center of the substring, and we can check if it's a palindrome along the way. Let me explain to you what I mean. Let's take civic again. So I'm gonna take civic. Let me write it one more time. We have C-I-V-I-C. Okay, so we have the letter C. Let's have the 2 pointers at C. First question, is C a palindrome? Yes, the letter C is a palindrome indeed. But then, instead of generating all substrings, no, we need to expand around the center, make C the center. So what do? Oh, let's decrease the left pointer and let's increase the right pointer. This way, C will be on the center. So here's the left pointer and here's the right pointer. We notice that the left pointer is out of bounds, so that's it. Enough of this string C. Go to the next letter, I. Okay, is I a substring of its own? Yes. Now, expand. Let's take the left pointer, it will go to C. Take the right pointer, it will go to V. Alright, now, is this CIV a palindrome? No, so that's it. We don't want the rest of these substrings right here. No, that's it. Okay, fine. Let's go now to V. Is V a palindromic substring? Yes, V is. Same thing. Take the left pointer, decrease. Right pointer, increase. Is I, V, I a palindromic substring? Indeed it is. So we have I, V, I. Let's keep expanding. So take left pointer, take the right pointer. Now we have civic as a whole word. Is it a palindromic substring? Indeed it is. So we have civic. Expand again. We notice this time both pointers are out of bound. So we stop. Now we go to the letter I. Again, we do the same thing with the expansion. So this is the main idea. Instead of generating all the substrings first and check if each one is a palindrome, no, we started each letter with 2 pointers. From that letter, we expand, making that letter the center. With each expansion, we check if it's a palindrome or not. If it's not, we stop, we just go to a different letter, we start the expansion once again. But let me show you an edge case really quick. It's not an edge case, it's a case we need to consider though. It's a bit tricky. Let's take this A, right here. So I have A. By the same notion, as we said, we have the 2 pointers. A is a substring, palindromic substring. Yes, we expand. The left pointer will be out of bound, then we stop. Go to the next one. A again, it is. Expand. Now we have the left, we have the right, so we have now A. Expand again, out of bounds. Then go to the next one. So we have the last A. Yes, it is. Of course, we need to expand. Left one will be here. Right one will be out of bounds. That's it. We finished all the, all the characters. So we have A. We have A. We have the 3 A's right here. Oh, we missed these two. And what do we notice? Both of them have even length. So how did this happen? How did we miss these two palindromic substrings and both of them have even length 2? Let's think of this again. Okay, again, if we start with the 2 pointers right here, then we expand. Okay, yes, this will go right here. This will go right here. I don't know. I don't understand. Let's try one more together. We start right here, but then we expand right here. Oh, wait, so at the beginning we have 1 letter, but then when we expand, total we have 3. Imagine if we have a longer string, let's say right here and right here. We expand again, we have 5, but then we will have 7. What do we notice? All odd numbers. Oh, so now we are only calculating the odd palindromic substrings. What about the even ones? How can we calculate the even palindromic substrings? So how did we end up in this odd in the first place? Well, because we started at 1 character and with each expansion we add 2 characters, we will get 3. At each expanding, we always add 2. We are always adding an even number. So an odd number plus even will always give us odd. 1 is odd, 2 is even, equals 3. 3 plus 2 is 5. 5 plus 2 is 7, etc. So we need a way to have the even ones. So what do we do? I'll show you. Instead of odd plus even equals odd, what about even plus even? Well, what do you mean? Let me tell you what I mean. We have the A. Instead of starting on 1 letter, let's take 2. Hey, is A palindromic substring? Yes, it is. So we have this one out. Okay, expand. Exactly the same algorithm. We need to expand. Okay, take this one to the left. This one is out of bound. Fine, let's go to the next one. So instead of the first 2 letters, go to these 2. Is AA, again, a palindromic substring? Yes, it is. We covered this case too. Expand. But now this right one will be out of bound. What do you see? We covered all cases. So let me summarize in one small sentence in 1 minute. Okay, we have a palindrome string. Okay, we said we need to start at one of the letters, then we need to expand. But then we said, oh, in one case we have odd palindromic substrings. In the other case, we have even palindromic substrings. So what do? It's the same algorithm. For the odd, we start at the first letter, but then we expand. For the even, we start at the first 2 letters, then we expand. And this is how we calculate all palindromic substrings. Now, the time complexity, I will explain it to you in detail, but before I do that, just to give you the overview, this would be O of n squared. Let me go code the solution with you and then come back and see exactly how we get O of n squared. Now, let's go to LeetCode and see exactly how we need to code this. First, we need to return the number of palindromic substrings. So I will initialize a variable called count, and this will store the number of palindromic substrings. This that we will return. I want to make my life easier, and I want to store the length of this string s inside a variable. I'm gonna call it n. So int n is equal to s dot length. So far so good. And now the algorithm starts. So we said we will have the 2 pointers on the first character, then we will expand around the center, and once one of the 2 pointers is out of bound, we will go to the next character. So we will start with a for loop, and we will say for int I is equal to 0, I is less than n, I plus plus. And then we said we need 2 pointers, so we will have int left is I. Both of them will start on the same character, at least for the odd palindromic substring. So int left is equal to I. We have right is also equal to I. And then we will have the while loop. Let me just put a space here to make it easier to read. Okay, so now we have a while loop. And we have, what are the conditions on the while loop? We said when one of the pointers go out of bound, we go to the next character. So we need to take care of the case where the pointers go out of bound. So while left is greater than or equal to 0, and right is less than the length of the string, and we need to check the characters on the pointers. s.char at left is the same at s.char at right. In this case, what do? Well, we have a palindromic substrings. Imagine we have the word bomb. Both pointers start at the first letter M. We are in bounds, but then we check, oh, does s.char left, it's M, s.char right is M. We have a palindromic substring, and we need to increase the count plus plus. But then we need to decrease the left pointer. We need to increase the right pointer. But in this case, let's keep on mom. We decrease left. Left is out of bound. So when we go to the while loop again, we will break the first condition. Left is out of bound now. So what happens? Oh, we go to the next character in mom, which has been taken care of in the for loop. But this only takes care of, as we said, the odd palindromic substrings, because we start on the same character. So we will do the same logic, exactly the same for the even ones. But this time, what is the main difference? Well, left will start at I, sure. But right will not start on the same character. It would be on the next one. So I plus 1. Exactly as we said on the algorithm. The while loop, exactly the same. So once we are done, hey, just return count. So let's return count. That's it. So let's run the code. We can see it works, but submit. We can see it worked. Okay, so we can see that we are using the same exact algorithm twice. So let's refactor. Okay, we kept saying we need to expand around the center, this idea of center and expansion. So I'm gonna make a helper function called expand around center. So public int expand around center, and this will take the string s, the left pointer, and the right pointer. So this is a different function, so the scope differs. I'm gonna store the length of the string s again in int n is s dot length. And for each character, once we want to expand around the center and see the substrings, we need to store the count somewhere. So again, int count, and I'm gonna initialize it to 0. Now, what is the algorithm? Well, exactly the same. So I'm gonna cut and paste. That's it. We just need to return the count. So let's just return count. Okay, and go back to the main for loop, and here we will have, okay, for each character we need to expand around the center. So let's just delete all of this one and this one, goodbye, and this one also. So what we will have in this for loop? Well, we will only have the following. we want the count plus how many substrings we calculate with the expansion function. So expand around center, and we will pass what the string is. And we said the 2 pointers for the odd palindromic substrings start on the same character. I'm gonna pass I twice. We need to do the same for evens on palindromic substrings. So let's copy and let's paste, but this time I plus 1. That's about it. Then we return the final count. So let's run again. And let's submit. Here we go. So I showed you how to write the brute force, the optimization, and how to refactor the optimization. Let's go back to the blackboard and explain the time complexity. So we said it's O of n squared. How is that? So let's say we have the word civic again. Well, we said we have 2 things we need to do. We need to find the odd palindromic substrings, then the even. For one of the cases, we start at the same character, then we expand. So we make one character the center. We went to C, we went to I, we went to V, etc. So each character at some point was the center for the expansion. So we have n centers for the odd case. What about even? Well, we said we need to consider 2 characters. So at one point, this would have been the potential center, then this one, then the VI, then the IC, because we have 2 characters, and this will be n minus 1 potential centers for the even case. Why is that? Why n minus 1? Well, we have 1, 2, 3, 4, 5, but how many potential even ones we have? We have 1, we have 2, we have 3, and we have 4. Try it again for the word, let's say nun. So we have n, o, o, n. We have 4 characters, but how many potential even centers? We will have 3. We have no, we have oo, we have on. So how many total centers we have? Well, we have n plus n minus 1, 2n minus 1. And to go through the whole string, well, this will be, bingo of 2n minus 1 or bingo of n. That's fine. But for each substring, we need to see if it's palindrome, right? And we said that will take also bingo of n. To check a palindrome, that will take bingo of n. So we'll have bingo of n times each one. We will see if it's a palindrome. This is bingo of n squared. One of the bingo of n's would be to go through all the centers. We have odd and even ones, but for each one of them we will see if it's a palindrome. That's going to be another bingo of n, so n times n squared. So that's it. Thank you guys for watching. I hope you enjoyed watching the question, and I hope you found it helpful. Take care until I see you on the next time. Bye bye.